This is a numerical problem on RTD and also combines the concept of operational amplifier. The question is stated as the junction semiconductor temperature sensor shown in the figure is used to measure the temperature of hot air. The output voltage V0 is 2.1 volts. The current output of the sensor is given by I equal to T microampere, where T is the temperature in degree Kelvin. Assuming the op-amp to be ideal, the temperature of the hot air in degrees centigrade is approximately dash. And this is the corresponding circuit for it. So it can be seen that this part of the network is a non-inverting amplifier. And over here, a current excitation or a current that flows from the top due to this temperature sensor can only flow through this 2 kilo ohm resistance, because the op-amp is an ideal one and therefore no current can enter the input terminal of the op-amp. So we can, right at the beginning, mark this node to have a voltage of small v volts, and due to the concept of virtual short implying that the voltage at the plus terminal of the op-amp should be equal to the voltage at the minus terminal of the op-amp, we can also claim that the voltage at this node should be equal to small v volts. And then small v is given by this current I multiplied by the 2 kilo ohm resistance. Now we are given the value of current I to be equal to T microampere, but note that T is in degree Kelvin, whereas in the solution they are asking for the temperature to be represented in degree centigrade. So we know that I is equal to T microampere, with T being in degree Kelvin, and the relation between degree Kelvin and degree centigrade can be used so that we can represent I in terms of T when it is in degree centigrade, and the formulation becomes I equal to T plus 273 microampere. So simply substitute this value of I in this expression of V is equal to 2 kilo ohms times I, and this leads to T plus 273 into 2 kilo ohms. Now because this is in microampere and we have the resistance in kilo ohms, this will lead to the value of small b being in millivolt range. This being a non-inverting amplifier, we can go forward and formulate the expression for the output voltage V0 to be equal to 1 plus Rf, which is 2 kilo ohms, divided by R, which is 1 kilo ohm, multiplied by the voltage at the positive node. So this becomes 1 plus 2 kilo ohm by 1 kilo multiplied by V, and this must equate to 2.1 volts, because it has been mentioned in the question that the output voltage V0 is 2.1 volt. Now if we substitute the value of small v from the previous equation and then take this 2.1 volt to be also represented in millivolt form, then we can cancel out the millivolt and we can do the little math and come up with the value of capital T to be equal to 77 degrees centigrade.